The height, h meters of a tree, t years after being planted, is modelled by the equation h squared is equal to at plus b for values of t between 0 and 25, where a and b are constants. Given that the height of the tree was 2.60 meters, exactly 2 years after being planted, and the height of the tree was 5.10 meters, exactly 10 years after being planted, find a complete equation for the model, giving the values of a and b to 3 significant figures. So what we want to do is replace the a and b with constants. Then after that, we're going to work on part B. We're given that the height of the tree was 7 meters, exactly 20 years after being planted, and then evaluate our model. So let's look at part A first. So we can use the values here and substitute them into the equation. T is 2, h is 2.60. So the 2.60 needs to be squared. So 2.6 squared gives me 6.76. So I have 6.76 is equal to 2a plus b. Let's call that equation 1. Now we're going to square 5.1 as well. 5.1 squared. That's 26.01. So 26.01 is equal to, and t is 10, so 10a plus b. And then we have simultaneous equations. Let's do 2 take away 1. So what we need to do is 26.01 take away 6.76. That will give me 19.25. 10a take away 2a is 8a, and b take away b disappears. So a is going to be 19.25 divided by 8. And that gives me 2.40625. Let's just check that value again. 2.40625. So 2.40625. And then we can substitute back into either equation to find b. So b would be equal to 6.76 take away 2 lots of 2.40625. And we can calculate that. So 6.76 take away 2 times my last answer gives me 1.9475. So in giving our final equation, we need to have both of these correct to 3 significant figures. So here that would be 2.41 with the 6 rounding it up. So that's going to be 2.41a. And then here, the 7 will round the 4 up and we'll get plus 1.95. Let's move on to part B. So after 20 years, the height of the tree was 7 meters. So substitute in the t equals 20. I'll put a there instead of t. So let's put t equals 20 into here. That would be 2.41 times 20 plus 1.95. So we have 2.41 times 20, add 1.95, it's 50.15. And then h would be the square root of that. So we just need to calculate the square root of the last answer. And that is 7.08 meters. this predicted value is close to the actual value, and therefore I would say that the model is a good fit.